sure I'm on the right. All right. Is what I have up here the same as what you have in front of you right now? Everybody's cool with that? Okay, well, let's go and run through this. Guys, everything that we've been doing in this section is really modeled everything that we did in the last chapter with equations, so today no different. We're going to start looking at multi-step stuff, and the multi-step stuff is going to force us to remember some things. But guys, in 2.4, titled Solving Multi-Step Inequalities, our essential question is, how do we solve a multi-step inequality? And some things that we're trying to accomplish here today will be the following. A volunteer would read that first goal for me. Thanks, Anna. Solve multi-step inequalities, and then down below it says use multi-step inequalities to solve real-life problems. So what's really going to be important, and this is going to be pretty short today, what's really going to be important for us today is to make sure that we're able to recall steps for solving equations. And it says this is going to definitely apply to solving inequalities. So just a quick review here. Guys, when we were looking at multi-step equations, what was the first thing we always said we had to do when we were solving those? Distribute if necessary. In other words, get rid of parentheses. Great. And then secondly said, if possible, combine any like terms. So if there were any like terms to combine, you had to do that if it was necessary. Third one right here says to get the variables to the same side, undo addition or subtraction, which you've done, undo multiplication and division for what you've done. Right? So to kind of get us thinking about what it is that we're going to do, kind of front loaded question here. How many of you guys have a bank account already? Anybody have a bank account? Your coffee can, I love it. I love it. You're old school. Okay? That's when the zombie apocalypse happens. You don't have to run to the bank, right? I thought it was happening the other day when I got power surge. Remember when we had that power surge? I thought the zombies were coming. All right. Some of those banks will say, hey, in order to keep an account open, you have to keep a certain balance in the bank. Do you guys have anything like that? Do you know what your minimum balance is? It has to be, so it's Veridian. Are you through Veridian? I think Veridian requires a $5 balance in there to keep it open. That's exactly right. So this is kind of what's going on in this question. It says your current balance in your account is $440. It says you must have a balance of at least how much to keep your account open in this one? $10. It says write and solve an inequality that represents how many $20 bills you can withdraw from the account without going below the minimum balance. Okay? I want you guys with a partner right here. Take about a minute, see what kind of inequalities we come up with. I don't care if we get this right now, we'll talk about what we're doing. But see if you can't come up with an inequality for this situation. And then I'm going to call on some people to give you an idea of what they've got here. See if you can't come up with an inequality here. Or maybe even a verbal model. You know, tell me what you might do. All right, guys, kind of describe to me what's happening in this situation. Anybody have an inequality written, or maybe what we would need to know or need to do in order to write an inequality for this? How much money are you starting with? Starting with $440. Okay, it looks like we pull into maybe an ATM or something like that to make a withdrawal. And it looks like we want to withdraw some money, but we want that money to be in what type of currency? What are we withdrawing out? The question is asking us, what are we trying to take out? $20. So we're trying to take out some $20 bills, right? Do we know how many? As many as possible. So that we don't go below the $10 minimum balance to keep your account open, right? Anybody have a thought on how we might do this? You said start with 440, we're subtracting some 20s, we want that to be more than 10, right? Want to take a stab, Emily?
You might do 440 minus 20x is greater than or equal to 10.
All right, so say that one more time.
440 minus 20x is greater than or equal to 10.
So you're saying, let me see if I can read this. The 440 represents the amount of money that we started with, right? We're subtracting some 20s, so 20 times the unknown number of 20s, where x is representing the number of unknown 20s. That expression has to be greater than or equal to 10. Why greater than or equal to 10?
Because it has to be x, because that has to equal at least 10 or more.
Perfect. Perfect. That was great. Okay. That's exactly the inequality we want right up there. Okay. So we're going to leave that up there, Emily. You hit it right on the head today. That's awesome. We'll leave that up there. We're going to come back and look at how we solve this here in a second. So, why don't you guys run off to the second page here quickly. We'll start looking at solving some multi-step inequalities as they would relate to this real situation. So, here we go. As example 1, solving multi-step equations, and that should say inequalities right here. I've made a mistake up here. So change this word right here to, change that to inequalities for me. Okay, so in the very beginning, guys, I said, hey, we're going to run through this just like we solved equations. So I'm going to ask myself, are there any parentheses to get rid of? Are there any parentheses in this first example? How about combining like terms? Anything combined? Any x's to put together at all, in other words? No? Are there variables on one side or two sides? Just the one. So we're ready to roll. We're going to undo addition and subtraction first. So to isolate x right here, what do I have to get rid of, guys? Plus 4. So what are you going to do to both sides here right off the bat in your notes? Well, you would minus 4. Now, guys, keep in mind, will addition or subtraction ever change the direction of your sign? Will addition or subtraction ever change the direction of your sign? Never. The only time is that last step when you multiply or divide specifically by what type of a number? Good. So help me out here, gang. What are you going to have on the left-hand side of the inequality when we do our subtraction property of equality? What's going to be left on the left side? X over negative 2, because the 4's cancel. How about negative 1 then minus 4? Negative 5 on the right. And we just got done saying, said, you know what, since we're subtracting, the direction's not going to change. So if I had greater than up top here, what do you still have here? Greater than. Okay, good. So then our last step is to undo any addition, undo a multiplication or division. What do you want to do here, Jacob?
X over negative 2 by negative 2.
So both sides times negative 2.
And the negative 2 on the left side cross out, so x is less than 10.
Why'd you go from greater than to less than?
Because multiplied by negative.
So in the process of solving that, multiply by a negative. Our solution here, x less than 10. Now just as a reminder, if I had to say, hey, graph this now, would you be open or close on 10? Open, and then our shading left or right? Left, right? Value's less than 10. Okay, good. That was awesome, you guys. Good. All right, so real quickly on your own, you guys give this one a shot. See what you come up with for this problem right here. 3c minus 2 less than or equal to negative 11. On your own, go ahead and do that. Talk that over with your table partner or someone around you if you're single. And if you disagree, talk about why you disagree. I got a volunteer that wants to come up and give this a shot for me. Jacob, you want to come up and do that for me? Jacob, make sure you give me an explanation so I know what I'm doing here when I try to do these problems today, all right?
Add 2 to both sides.
Okay, so Jacob's saying add 2 to both sides. Show of hands, how many agree with that first step? All right, Jacob, you can't see it, but they're all up, okay?
C is less than or equal to -9.
Okay.
And then divide by 3 on both sides.
Okay.
So C is less than or equal to -3.
Now I see a -9 up there, so we should have switched the sign, right? Just like going to the reports part, see if all right, sound good. Okay. How come you didn't switch the sign? I see a negative value right up here. I see -9 right up here, so we divide by 3 and it should change, right?
No, because we divide by positive.
Yeah,
We
it's-
only divide by.
It's the value in the bottom, not the one on the top, right? So excellent, Jacob. Very good. How many had that, by the way? Awesome. Very good. Okay. Well, same stuff here, guys. Let's look at some examples with variables on both sides. If you have variables on both sides, you guys know enough already to say, I don't want variables on both sides. It should be on the same side. So as I look at this first example right here, what do you want to choose to move? You want to move the 3x or the 5x? How much?
5.
Okay, we'll move the 5x. Could I move the 3x if I wanted to? Does it matter? That's the nice thing about it. So you want to move the 5x. We have a positive 5x on both sides, so I'm going to subtract 5x from both sides so that we isolate variables to one side. Now, a lot of you might have chosen to subtract 3x. That's fine. What are the 5x's going to do on the left, kids? Yep. We have -6 greater than or equal to, help me out, 3x minus 5x. -2x, good? All right, 2-step me through this. 2-step me through this. What's next?
We're gonna add 4. I mean, subtract 4.
Yep, subtract the 4. Subtract the 4. So I'll squeeze this in over here on the right side. So on the left side, -6 minus 4 more is -10. That is greater than or equal to -2x. So finally, our last step, divide by -2. Sign switching or staying the same? Switching, yep. So this will be 5. What's going to happen here in the middle? You just told me to turn greater than or equal to into what? Now, if you want to leave your solution like that and be done, that's fine. Some of you may not like that and want the variable out front. So if I switch stuff around, this would be equivalent to x greater than or equal to 5. So either this will do or this will do. Okay. Do I need to do another one of those? Yes, no, yes, no, yes. Okay. So this last one right here. Is it okay if I move from the other side this time? Instead of moving to 3x, is it okay if I move to 7x? All right, so let's do that. So -7x on both sides. How about 3x minus 7x? 3x minus 7x, -4x. Less than 10, then when they cancel, add 2 to both sides, you got -4x, less than 12. What are you going to divide by, guys? What are you going to divide by here now? -4. So when I divide by -4, I've got an x. Since I divide by a negative, less than shall turn into greater than. And then finally, 12 divided by -4 is? There it is. Very good. Okay, very good. Multi-step stuff. We okay with it so far? Is there anything really different we've done? The only thing you really need to keep track of is the sign direction, right? The only thing you need to keep track of is the direction of the sign. All right, last page here quickly. So sometimes an inequality may or may not have a solution, just like some of the equations. Some had a solution, some did not. All right. Well, same game here. Check this out. Guys, do we have parentheses all of a sudden in this example? We do. So we better deal with the right side right off the bat. So I'm going to leave the left as is. I've got this as 6t minus 4. And that's going to be greater than, help me distribute. What's the 2 times 3t, kids? 6t. As in 6 variable t, not 6d, the number. What's the 2 times the 5 going to get you? Plus 10. Guys, notice that we have variables on both sides. Furthermore, what's true about the variable on both sides? Are they the same or are they different? I'm going to subtract 6t from both sides. And this time, instead of a variable falling out of one side, the variables actually fall out of how many sides here, guys? Don't they fall out of both sides here? Okay, so we get this goofy comparison right here when everything falls out. What's on the left side? We have this comparison that says -4 is greater than, what's on the right side? Now, as the variables have fallen out, we can't really solve for a variable anymore. So what this implies is the following. You look at your comparison, -4 greater than 10, and ask yourself if it's valid or not. Is that true or false up there? It's false. This turns out to be a false statement once it drops out of both sides. So if anything like that ever happens where variables just dump on both sides and you get a false comparison, what do you think this means about the number of solutions here? There's not going to be a solution here. No solution. There is no solution. Okay? Now what do you think would happen if the statement would have turned out true? What would you have said there? Instead of no solution, you might say many solutions. So let's look at this on your own one together. Guys, help me distribute on the left. What's 2 times 2x? 4x. And 2 times -3 would be -6, wouldn't it? What are going to happen to the 4x's on both sides when I get rid of 4x on one side? It's actually going to drop out on both sides. And here's that comparison. This time ask yourself, if the variables dropped out of both sides, is that comparison true or false? What do you find out in this thing? Is that true or false statement? -6 less than 9. This is true. So in a situation like this, if the variables fall completely out and you end up with a true comparison, instead of no solution, we should say what here? Many solutions. Many solutions. Very good. Very good. Multi-step process part makes sense for sure. Okay, I'm going to go back to the one that's Emily kind of talked to us right here. Guys, the way that Emily modeled this problem right here with inequalities, does this look like a multi-step inequality that we're going to have to solve? It does, doesn't it? Okay, so there's application for it. So let's look at that last example on the back side of your notes here. We'll do that. And then I'm going to leave that front-loaded question for you guys to finish up here. Pretty easy stuff today, I think. All right, so in this last example, guys, it says you have some grades on 4 math tests. All right, they give you those scores right here. You have a score of 79, 85, 86, and 88. It says we want to average at least how much, guys? 85. It says, what's your grade on the, or it says, what grade on the 5th test will give you an average score of at least 85? Okay, remind me what average is again. Remind me how to find average again. Okay, you're going to take all your numbers, add them up, and then divide by how many there are. Well, in this case right here, how many test scores do you know? How many test scores do you know? You know 4 of them, right? But you're going to take a 5th test, right? And you want to know what you have to get on that 5th test in order to average and 85 or better. So here's the deal. The way we're going to set this up is as follows. We're going to take the 79 first test plus the 2nd test score, which was what? plus the third test score, which we knew was 86, plus the fourth test score of, okay, we know a fifth test is coming. I don't know what I've gotten on the fifth test, but I would like to know what I need to get. So I'm going to call that the X. How many tests are up here now? 4 of them known, 1 unknown. How many are up there? So to find the average of all these values, what am I going to have to do to both sides, guys? If I say I want an average of at least 85, this is saying this expression, this mess right here, your 5 test scores added up divided by 5, would that have to be greater than or equal to 85, less than or equal to 85, or what? Well, wouldn't you want to be greater than or equal to 85 if 85 is an average you want? Because 86 would work, right? 87 is good. 92 would be good. So we want this expression to be greater than or equal to what here? Greater than or equal to 85. All right, so help me do some arithmetic here. I've got to get this fraction part out of here. So I'm going to take 5 times what first? 85, okay? So we're going to multiply both sides times 5. So let's do that. Times 5 here, times 5 here. Okay, let's cheat this a little bit. How about this? First of all, what are the 5's going to do to each other on the left side? They're going to cancel, all right? Do I have a volunteer willing to add up the first 4 scores that we know up here? Okay, go ahead. I'll try and beat you. 319, 338. You beat me. 338 plus what on the left? What do I have to do on the right side? Whoops, I already made a mistake. See, I'm guilty of it. Did you see what sign I just put in there? I just threw an equal sign. Habit. What sign do I need to put in there? 85 times 5, what is that? 425. Let me ask some questions, guys. Do you understand where the 338 just came from? 338 represents the first 4 test scores all summed up, right? The X is the 5th test that we need to take in order to average 85. In order to average 85 over 5 tests, how many total points do you need to get? See where we're coming from there? What are you going to do to both sides, kids? Subtract 338 from both sides. If I'm not mistaken, is that 87? So what this means is this. If X is greater than or equal to 87, if X is greater than or equal to 87, this implies that I have to get 87 or better on that last test to at least average an 85. So what I might say here is this. You need to score of 85 or better. Is it okay if I write 85 plus? Is that okay? 85 plus, 85 or better. Have you seen it written like that before? Give me some sort of sign to your library. That false? All right. How you guys feel about this? Pretty good? Pretty easy? All right. Here's what we're going to do then the rest of the day. Let me know that you have this down. Does everybody have this down? Lily, have you got it? I see your pencil. You all good there? Good. Jacob, did you get it? I saw your pencil move. Good to go? Awesome. What's that? Okay, very good. Here's what I want to do today, guys. I do have a short quick quiz. I'll hand this out. Quick quiz 2.4. Let's get that done in class. Guys, the 2.3 online book page, you know let's do what time today? That's 4 o'clock today, right? Okay, I haven't sent out 2.4 yet today, so I'm going to send that out to you. And this new one that you get, online book page 2.4, let's go ahead and make this due for Thursday. So you've got a couple of days on that. Thursday at 4 o'clock. I'll send that to you while you're taking a quick quiz here then, okay? Have you guys got any questions about what we discussed today? Mason? No? Anybody? Going once? Twice? Awesome.